Let's say we're interested in solving the equation x over 4 plus x over 6 is equal to 10. A fractional equation, that is an equation that has fractions in it. Okay, now the easiest way to handle a problem like this is simply to get rid of the fractions. Mathematically, what I'm going to do is multiply both sides of this equation by a number sufficiently large to clear all fractions. Okay, now the easiest way of going about this is to find the least common denominator of all the denominators in the problem. Okay, when the denominators are all numerical like this, we're looking for the smallest number so that all the denominators evenly divided. Okay, now in a pinch, a common denominator can always be found by taking the product of all the denominators. For example, 24 is a common denominator, and multiplying both sides of this equation by 24 will certainly clear all fractions. It has not, however, the smallest of the common denominators, or the least common denominator. Okay, to find the least common denominator, what we do is we factor each of the denominators completely. If they're numbers, we take them down to their prime factors. And then we take each factor the largest number of times it appears in any one denominator. So, for example, over here, 2 appears twice as a factor. It only appears once here, so we will take it twice. In the problem, 3 appears no times in this denominator, 1 time in this denominator, so we will take it once. And we see in this very simple problem, of course, that the LCD, the least common denominator, is 12. That is the smallest number, so that 4 and 6 evenly divided. Now, if we multiply both sides of this equation by 12, we will certainly clear all fractions. We could have done it with 24, and in a pinch, you can use the product of the denominators. But when we get algebraic expressions in our denominators, that can get a little bit complicated. So it's best to have, if possible, the least common denominator. Okay, so in this example, we will multiply both sides of the equation by 12 in an attempt to clear fractions. Okay, we will multiply both sides of the equation by 12. In doing so, we will multiply each and every term here by 12. 12 times x over 4 plus 12 times x over 6 is equal to 12 times 10. Okay, now this number 12 has been chosen so that 4 and 6 both divide into it. Okay? Therefore, we will not have any fractions when we simplify here. 4 goes into 12 3 times, so this leaves us with 3x. 6 goes into 12 twice, plus 2x is equal to 120. That is 5x equals 120. And dividing both sides of this equation by 5, we get x is equal to 24 as our answer. Let's check our answer, and as always, we go back to the original equation, not any simplified version of it. You could have made a mistake in simplifying, so you always go back to the original equation. We let x equal 24 in the original equation, and we hope that it's going to check out. 24 over 4 plus 24 over 6 should be equal to 10. 6 plus 4 should be equal to 10, of course. 10 is equal to 10. It checks out. Okay, now I want to point out that there is a difference between solving a fractional equation of this form and simply adding fractions. If somebody says, add the fractions x over 4 plus x over 6 plus 10. Somebody says, add these fractions. Then you cannot say multiply both sides of the equation by 12 because we don't have an equation. Okay? We cannot get rid of the denominator in this problem. There's a big difference. Here you had an equation. Okay? You can multiply both sides of the equation by 12 and clear all fractions and simplify your work. We had an equation. Look at the equal sign. This was an equation. Here, however, we just want to add fractions. If you're just adding fractions, you cannot eliminate the denominators. Okay, the way to add fractions, of course, is to combine, is to try to build fractions equivalent to each of these that all have the same denominators, because if your fractions all have the same denominators, you can simply add up their numerators and combine over that denominator. We have denominators here of 4, 6, and 1. The denominator of 10 is 10 over 1. In each case, we're going to build a fraction equivalent to this fraction. Okay, that has the same, and they're all going to have the same denominator. Once again, the LCD in this problem is still 12. So we're going to try to build fractions equivalent to each of these with denominator 12. Using the fundamental principle of fractions, what we do is we are always permitted to multiply numerator and denominator of a fraction by the same number or the same quantity. In the first case, if we multiply top and bottom of the fraction by 3, okay, we will be able to build a fraction equivalent to the original one whose denominator is 12. Okay, we say to ourselves, what was done to 4 to get 12? The denominator was multiplied by 3, therefore the numerator has to be multiplied by 3 as well. 3x over 12, of course, is the same as x over 4. We do not now reduce. We are trying to get the same denominator. 6 times 2 would give you 12, so multiply the numerator by 2 as well. 1 times 12 gives you 12, so multiply the numerator by 12 as well. And here we have 3 fractions, all with the same denominator of 12. To add these fractions, you combine the numerators over the common denominator. 3x plus 2x, that's 5x plus 120 over 12. Okay, so don't confuse these problems. Here we are adding fractions. Over here we were solving a fractional equation. This was to solve for x. This was to add fractions. When you add the fractions, you still wind up with a fraction here. Same denominator, 12. Okay, let's move on to a slightly more complicated problem in fractional equations. We want to solve for x. 10 over x minus 3 minus 2 over 3 is equal to 38 over 3x minus 9. We are looking once again for the LCD. We look at the factors. We look at the denominators. We factor each denominator completely. X minus 3 is already factored as far as it can be. 3 is already factored. 3x minus 9 can be factored further. You can take a 3 out and be left with 3 times x minus 3. 3x minus 9. So therefore, the LCD is 3 times x minus 3. There are only 2 types of factors, x minus 3, which occurs once, 0 once, so we put it in one time, and 3, which occurs 0 once and once. Okay, so we put it in once. Remember, we take each factor the largest number of times it appears in any one denominator. So the LCD is 3 times x minus 3. We will multiply both sides of this equation by 3 times x minus 3 in order to clear fractions. Let me do that up over here. 10 over x minus 3 minus 2/3 is equal to 38 over 3x minus 9. We're going to multiply each and every term here by 3 times x minus 3. So we'll get 3 times x minus 3 times 10 over x minus 3 minus 3 times x minus 3 times 2/3 equals 3 times x minus 3 times 38 over 3x minus 9. We are multiplying each term, okay, by 3 times x minus 3. We're multiplying both sides of the equation by 3 times x minus 3. Okay, and in doing so, we will remove all fractions. In the first term here, the x minus 3's cancel, and we are left with 3 times 10, or 30. Minus, here, the 3's cancel, and we're left with 2 times x minus 3. Here, 3 times x minus 9, of course, is 3 times x minus 3, and that exactly cancels that, so we're left with just 38. We get 30 minus 2 times x minus 3 in parentheses is equal to 38. All right, now we will distribute the minus 2. Be careful here. It's minus 2 times the plus x is minus 2x. Minus 2 times minus 3 is plus 6 equals 38. This gives us 36 minus 2x equals 38, adding the 30 and the 6. Now we would like to solve for x. We'd like to get x alone on one side of the equation. We will subtract 36 from both sides of this equation and get minus 2x is equal to 2. And finally, to get x alone, we will divide both sides of the equation by minus 2 and get x equals 2 plus 2 over minus 2 gives you minus 1. X equals minus 1. Now let us check our answer. In the next example, you're going to see that these checks are not just an exercise in tedium. They're really very important in fractional equations. Let's go, in this particular problem, let's check. Here was our original equation. You must always go back to the original equation, not the simplified version of it. We are going to check x equals minus 1. So we'll go through the equation. Every time we see an x, we will write minus 1 and see if it works out. 10 over minus 1 minus 3 minus 2/3 should be equal to 38 over 3 times minus 1 minus 9. Now, what you do is you work with the left side separately, the right side separately, and hope that they come out to be equal to each other. Okay, 10 over minus 4, or minus 10/4, minus 2/3. This is minus 5/2 minus 2/3. Here I divided numerator and denominator by 2 to reduce. And now to combine these fractions, I have to get them over the same denominator. The lowest common denominator here is 6. So we ask ourselves, what was done to 2 to get 6? We multiplied by 3. Therefore, the 5 also has to be multiplied by 3 as well. Over here, what did you multiply by 3 to get 6? You multiplied the denominator by 2. Therefore, you must also multiply the numerator by 2. It's perfectly okay to multiply the top and bottom of a fraction by the same quantity, but you must do it to the top and the bottom. Here we multiplied top and bottom by 3. Here, top and bottom by 2. To get two fractions that had denominator 6, we can now combine. Minus 15/6 minus 4/6 gives us minus 19/6 on the left. And let's see what we have on the right. We have 38 over minus 3 minus 9, 38 over minus 12. Dividing numerator and denominator by 2, we see that we get minus 19 over 6, which is what we wanted. The left and the right sides do check out. Okay, so x equals minus 1 is the answer to this problem. Okay, for our next example, let's try this. X over x minus 4 plus 3/5 is equal to 4 over x minus 4. Another fractional equation. Once again, our object will be to solve for x. Try to find all those values of x which can be substituted in and make this into a truth statement. Okay, in this particular problem, it's fairly obvious what the LCD is. It is simply 5 times x minus 4. All the denominators are already factored. So we will multiply each and every term by 5 times x minus 4. Multiply both sides of the equation by 5 times x minus 4. We get 5 times x minus 4 times the first term, x over x minus 4, plus 5 times x minus 4 times the second term, 3/5, equals 5 times x minus 4 times the right side, which is 4 over x minus 4. We now try to simplify. Over here, we can divide numerator and denominator by x minus 4, and we are left with 5x. Here we can divide numerator and denominator by 5. We are left with 3 times x minus 4 equals, here the x minus 4's cancel. We are left with 5 times 4, or 20. All right, 5x plus 3x minus 12 equals 20. Distributing the 3 through the parentheses. 8x, combining the 5x plus 3x, minus 12 equals 20. Add 12 to both sides. 8x equals 32. Divide both sides of the equation by 8, and we get x equals 4. And as always, we must check our answer. We go back to the original equation, which was x over x minus 4 plus 3/5 is equal to 4 over x minus 4. Substitute in the value that we have found, x equals 4, and see if we get it to work out. Okay, so we let x equal 4, and we get 4 over 4 minus 4 plus 3/5 should be equal to 4 over 4 minus 4. And the first thing that we see is that 4 minus 4 is 0, and you're not allowed to divide by 0 in our mathematics, so what has gone wrong here? We did all the right things, we made all the right moves, the same moves that we made in the last problem, and here we wound up with something very strange. When we try to substitute back in to check our answer, we see that it leads to division by 0, and certainly it is not the correct answer. Now, one thing before we go any further, this is one of the reasons you do not go to some intermediate step. If you had tried to substitute in, say, over here, it would have worked. You always go back to the original equation, the equation that was originally given to you. That's where you work, before you've done anything else. Okay, now, what's gone wrong here is, well, you know, we have certain rules, things we're allowed to do to an equation to get an equivalent equation. We are allowed to add a quantity to both sides of an equation. That's perfectly okay. Or subtract the same number from both sides of an equation. When it comes to multiplication, we are allowed to multiply both sides of an equation by a non-zero quantity, and we will get an equivalent equation. Something happens if you multiply both sides of an equation by 0. Let's say we start with something which is patently false, 3 equals 4. If you were to multiply both sides of this ridiculous equation by 0, you would get 0 equals 0. It would lead you to believe that it was correct. In other words, you no longer get the same type of equation, and this could be false, and when you multiply by 0, you get something which is true. And in a sense, this is what we did over here. We multiplied both sides of the equation by 5 times x minus 4, the LCD, and in doing so, we had to assume that that was not 0, or we wouldn't necessarily get an equivalent equation. But what happens at the end? X is equal to 4. Which means 5 times x minus 4 was 0. We were really multiplying both sides of this equation by 0. And the solution that we got was not necessarily a solution to the original equation anymore, because we were multiplying by 0. Okay, now you can worry about this before you start the problem. You can say, look, if that's the LCD, if that's what I'm going to multiply both sides of the equation by, I will never accept an answer which is equivalent to that being 0, which results if you set that equal to 0. In other words, I will never accept x equals 4 as an answer. So should I get it, I will throw it out. But you don't even have to be that clever. You don't have to think about it in the beginning. You can start all your problems the same way. But if you multiply both sides of an equation by an expression involving the variable, okay, if your LCD has variables in it, you must go on and try to check it. Okay, there's no question about it. All fractional equations must be checked, because you might have unknowingly been doing something like this. You get a perfectly, looks nice. There's nothing in this answer to indicate that it's something wrong with this and the other one was correct. You won't know until you try to check. If when you try to check, okay, you get something like this, division by 0, then you know that your answer is incorrect. There is no solution to this problem. The only possible solution was x equals 4, and that is incorrect. Therefore, there is no solution whatever. Okay, now sometimes you can get a very difficult number to work with in a fractional equation. It can be a fraction, something complicated. The original equation might be complicated. If you find it difficult to go all the way through the check, Okay? All the way through the check would tell me that your arithmetic was correct. But the first line of the check, that is the one that'll tip me off if you've made a mistake and, say, multiplied through by 0 and didn't know about it. So at least go to the first line of the check, okay? And make sure you don't have any division by 0 there. If you don't have any division by 0 there, you'll be okay. You don't really have to complete the entire check if the numbers are very complicated. Okay, but at least you must, in a fractional equation, you must go as far as the first step in the check, to make sure that you do not have division by 0. And if you do, you must cross your answer off as being incorrect. There is no solution to this problem. Okay, no solution. There is no value for x that you can substitute in that will make this a true statement. Okay, let's move on to the next problem. 9 over x plus 6 is equal to 3 over x. We would like to solve this fractional equation, find the x values, which when you substitute in give you a true statement. Once again, it's rather simple to find the LCD. It's simply x times x plus 6. In this case, it is the product of the denominators. I mean, sometimes it does come out to be that simple. Okay, we multiply both sides of the equation by x times x plus 6, and we get x times x plus 6 times 9 over x plus 6 equals x times x plus 6 times 3 over x. On the left side of the equation, the x plus 6 is canceled, and we are left with 9x. On the right side, the x's cancel, and we are left with 3 times x plus 6. To solve this equation, we will distribute the 3 through the parentheses. 3x plus 18 equals 9x. Subtracting 3x from both sides of the equation, 6x equals 18. Dividing both sides by 6, x is equal to 3. We believe this is the answer. We are now a little more cautious because we've seen what can happen, so we will immediately check our solution, what we believe to be our solution. We will go back to the original equation and substitute in x equals 3. We'll get 9 over 3 plus 6 should be equal to 3 over 3. And this happens to work out very nicely. We get on the left 9 over 9, and on the right 3 over 3. And of course, the left side reduces to 1, and so does the right side. You can sort of do them line by line, working on the left and the right, or as before, you can draw a line down the middle. Sometimes one side requires a good deal more work than the other side, in which case it's a good idea just to draw the line, work with one side all the way, and then work with the other side. Okay, x equals 3 is the solution in this case. Okay, a word about this problem. It's a little different from the ones that we've had earlier in that what we have on the left side of the equal side is just one fraction, and on the right side also one fraction. It's in the form, say, a over b is equal to c over d, this type of fractional equation. And we multiply both sides by the LCD. Some people, okay, might be thinking, gee, there's an easier way to get to this step. I learned something called cross-multiplying, where you say, I will multiply what's in the upper left here by the lower right here, 9 times x, and set that equal to the lower left here times the upper right there. 9 times x equals 3 times x plus 6. Okay, that's just a shorter way in this particular problem doing it. It's the same, you get the same thing, of course, by multiplying both sides by the LCD. The next line, this comes out. In fact, sometimes when you cross-multiply, you get a more complicated equation than you would have gotten if you used the LCD. Because when you're using the cross-multiplication, you are, in a sense, assuming that the common denominator is a product of the denominators. And sometimes you can do much better than that. Okay, so if you want to use the cross-multiplication, or if you are used to using it, there's nothing wrong with it, so long as you remember it is only valid when you have one fraction equals another. It could not be used in a problem like this. Okay, any of the other ones that we had today, when you had, say, the sum of two fractions is equal to a third fraction, you could not cross multiply. It is only valid when you have one fraction equal to another, like we have over here. One fraction equal to the other, then you can say AD equals BC, assuming, of course, the B and the D are not 0. And it's perfectly okay to say AD is equal to BC and to solve from there. It is the same thing that you would get if, I mean, eventually you would get there if you multiplied both sides by the LCD. You can see that right here. Okay, so the LCD method will always work. Those of you who are used to using cross multiplication, okay, so long as you only use it when it's one fraction equal to another. Okay, let's try one more problem, and that'll be it for the tape. This fractional equation has a quadratic expression in the denominator, but it's basically handled the same as the other ones. 2 over x minus 1 minus 1 over x plus 1 equals 5 over x squared minus 1. If you want to, you can try this problem on your own, shut the tape off, try the problem, and turn it back on when you think you have found the solution. So we're going to try to solve this equation for x. First thing, of course, we have to find the LCD. This denominator is factored as far as we can here. This denominator as well. X squared minus 1 is the difference of two squares. You will remember from our tapes on factoring, this can be written as x plus 1 times x minus 1. You can, of course, check this by FOIL. X squared minus 1x plus 1x, they drop out, minus 1. The difference of two squares. The sum of the numbers times the difference in the numbers. So the LCD is just x plus 1 times x minus 1. Okay? We are going to, in fact, you can write this right here as x plus 1 times x minus 1. We're going to multiply both sides of this equation by x plus 1 times x minus 1 in an effort to clear fractions and make solving a little easier. X plus 1 times x minus 1 times the first term on the left, 2 over x minus 1, minus x plus 1 times x minus 1 times 1 over x plus 1 equals x plus 1 times x minus 1 times 5 over x squared minus 1, but x squared minus 1 is just x plus 1 times x minus 1. We took our original equation, multiplied each and every term by x plus 1 times x minus 1. Now, in the first term, on the left here, the x minus 1's cancel, and we're left with 2 times x plus 1, minus, here the x plus 1's cancel, and we're left with minus 1 times x minus 1. Here, both the x plus 1 and the x minus 1's cancel, and we're simply left with 5 on the right. To finish this off, we will distribute the 2 through the parentheses, 2x plus 2. Now distribute the minus 1. Minus 1x, or minus x, minus 1 times minus 1 is plus 1, equals 5. Combining like terms on the left side of the equal sign here, 2x and minus x, that's 1x. 2 plus 1, that's 3, equals 5. Subtracting 3 from both sides, we get x equals 2 as a possible solution And we're going to check that to see if it is, in fact, the solution to the problem. To check it, I'll go back to the original equation. Every time I see an x, I will write 2. I'll get 2 over 2 minus 1 minus 1 over 2 plus 1 should be equal to 5 over 2 squared minus 1. I will go back to the way it was originally written, not the factored form, because after all, I could have made a mistake factoring. So go back to the original equation. Here we have 2 over 2 minus 1, which is 1, minus 1/3 should be equal to 5 over 4 minus 1, 5/3. If we remember that 2 is the same as 6/3, because we can build a fraction equivalent to 2 that has the same denominator as this one, 3. Multiplying numerator and denominator by 3, that's 6/3 minus 1/3. And of course, that is exactly equal to 5/3, which is what we have on the right. So the answer is correct. This is the solution to the problem, x equals 2. And that brings us to the end of the videotape.